When solving from factored form, all we have to do is take each factor and set it equal to 0. So we have 3x plus 5, now it's going to equal 0, and x plus 1, we set it equal to 0. Then we just need to solve for x. So subtract 5 from each side, so I get 3x equals negative 5, and then I want to divide each side by 3. So this first one, x would equal negative 5/3. In the second factor, we subtract 1 from each side, x equals negative 1. And that's how you're going to solve all of these. When we get down to number 6, there's only one thing we have to be careful of. There's still two factors here. We can put this in parentheses. So I'll say x equals 0 and x plus 5 equals 0. This first one's already solved. We don't have to worry about that. And on the next one, we subtract 5 from each side. So x equals negative 5. When we solve from standard form using the factoring method, we have to remember that it is telling us to solve, and it's telling us which method to use. So factoring method. For the first one, I have to make sure that my equation equals 0. So I'm going to subtract 7 from each side. So I get n squared minus 2n minus 48 equals 0. I'm going to put that into my big X, my bottoms up. So I'll have 1 times negative 48 on the top, negative 2 on the bottom. Each of my factors will be divided by my a value, which in this case is 1. So I need to find two numbers that will multiply together to give me negative 48, but they add to equal negative 2. And if you're having trouble with this, you can always make your factor list. So I have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, and that's all of the factors that can be made 48. So I'm going to find two numbers that when I subtract equal negative 2. And that's going to be my 6 and 8. So I'll have negative 8 and positive 6. Now, when I write my factors, that is when I have, and I wrote x, but it should be in x minus 8 and x plus 6. And this is what happened on the quiz, that a lot of people left it like this. But remember, when we're solving, we actually want to set each of those factors equal to 0. So my final answer is x equals positive 8 and x equals negative 6. I set both those things equal to 0 and then solve from there. Let's look at number 10. When I add 5 to each side for number 10, I'm left with x squared minus 36 equals 0. Well, if I put that into my bottoms up, I have 1 times negative 36, the 0 on the bottom. I do two numbers that will multiply to give me negative 36, but when I add those same two numbers, they equal 0. So that's going to give me negative 6 and positive 6. So my two factors are x minus 6 and x plus 6. So remember, I want to set that equal to 0 and then solve that. So I get x equals positive 6 and x equals negative 6. Now, if I look at number 12, same thing, it's got to equal 0 when I get ready to solve. So I'm going to add 5 to each side. When I add 5, I get 9m squared plus 15m minus 14 equals 0. Still want to take my a, b, and c value and put it into the bottoms up. So 9 times negative 14 will go on the top, which equals negative 126. And then 15 goes in the bottom. I'm dividing each of my factors by 9. So if I needed to create my factor list of 126, it'd be 1 and 126, 2 and 63, 3 and 42, 4 won't go, 5 won't go, it'd be 6 and 21, and then I can see right here that this would be my two factors. So I have positive 21 and negative 6. I just want to reduce each side. So 3 will go into 21 7 times, 3 will go into 9 3 times, 3 will go into 6 negative 2 times, 3 will go into 9 3 times. When I get ready to write my factors, I want to remember the swing method, so my denominator swings back and goes with the variable. while my numerator swings forward to become the constant. So 3x plus 7. On the other side, my denominator swings back to be with the variable, so 3x, and the numerator becomes the constant, minus 2. Remember, I'm still not quite done though, because when I do this, I still have to set each one equal to 0. So my two solutions should be negative 7 over 3 and x equals 2 over 3. When we move to the graphing section, the way we want to start this is set each of the factors equal to 0. So x plus 2 equals 0, which will give me x equals negative 2. And then x plus 6 equals 0, and that'll give me x equals negative 6. Now these are going to be my roots. So when I get ready to answer my questions at the bottom, it says vertex roots and axis of symmetry. For my roots, I can go ahead and plug in negative 2, 0, and negative 6, 0. But remember, in order to find my vertex, I need to find the midpoint of these two x values. So I'll do negative 2 plus negative 6. We're going to divide that by 2. Negative 2 plus negative 6 gives me negative 8. So I divide negative 8 by 2. So I get the x value of my vertex to be negative 4. That's going to go in the middle of my chart because I want to find the x values that are all around my vertex to create that sandwich. So I'm going to choose other x values of negative 5, negative 6, negative 7, and negative 3, negative 2, negative 1. Now, if you remember, the axis of symmetry is just the x value of the vertex. So that's going to be x equals negative 4. In order to find the y value of the vertex, though, this is where I need to take negative 4 and plug it back into the original equation. So the original equation was y equals negative 2. So we're going to type in negative 4 plus 2, and then negative 4 plus 6. And when I put all that into the calculator, I get positive 8. Now you can use your table function from here on out. You just want to type in this equation when you go to edit function. Or if you needed to plug it in by hand, you could say negative 2 times negative 7 plus 2, and then negative 7 plus 6. But if you just use your calculator, we can go from our roots that we know that negative 2 equals 0. We also know negative 6 equals 0. Our other values here are 6, and then when I plug in negative 7 and negative 1, I get negative 10. And this is just calculator work. Then I'm just going to graph these same points into my graph that's here. So negative 2, 0, negative 6, 0, negative 7, 10. Also gives me negative 1, 10. So this is what the graph would look like when you just connect these points. Don't forget to answer your vertex, and notice I did not give the y value of my vertex. That would be negative 4, positive 8. You have to have two roots. You also have to have your axis of symmetry. When solving the equations by using the square root method, all we want to do is get the x squared by itself. So what I need to do for number 17 is subtract 8 from each side. When I do that, I have x squared equals 20. Well, in order to get rid of the x squared, all I need to do is take the square root of each side. Remember, when we take the square root, you always are going to have two answers. So that's going to be positive and negative square root of 20. But you cannot leave it square root of 20 because square root of 20 can be simplified. So the factors of 20 are 10 and 2. Factors of 10 are 5 and 2. So now we're going to look for pairs because we have factored this to all prime numbers. So a pair of 2s, that means they're going to leave the radical and come on the outside. And a singular 5 is going to be left on the inside. So when I write my answer in simplest form, it's going to be x equals plus or minus 2 on the square root of 5. Now, when we look at a problem like number 22, notice that I have parentheses here. I'm going to still start by adding 16 to each side. So I get x plus 2 squared equals 16. But I don't want to get x squared by itself. I'm going to go ahead and remove the squared by taking the square root of each side. So x plus 2 will equal plus or minus 4, because remember we have to have two answers. Now here we have to make sure that we add 2 each side. So I need to have x plus 2 equals positive 4 and x plus 2 equals negative 4. Then I'll subtract 2 from each side. So x will equal 2. When I subtract 2 from this side, x will equal negative 6. One thing to remember is that if you have a square root of a negative, that cannot happen. So that means that the answer is no solutions. For this next section, they've told me to solve by completing the square. And if I'm going to complete the square, the first step is to group my ax squared and my bx values together. So for number 25, that means I would group n squared plus 4n. The next step is to actually complete this square. So I'm going to have n squared plus 4n plus a blank. That's going to, we want to bring down our plus 12. But now we need to balance our equation, so I need to subtract off whatever I'm going to put in, and that's still going to equal 6. Well, to complete the square, I need to ask myself, what is half of the b value? So what is half of 4? And half of 4 is 2, so we want to square that on the first blank. So I am putting into the equation 2 squared. And to keep everything nice and balanced, I need to also take it out of the equation, which is why I'm going to subtract 2 squared as well. The next step is to write in vertex form. So I'm going to use this value that was half to go inside my parentheses. So n plus 2 squared. We're going to add that to 12, and then we also need to subtract 2 squared, which is 4. We just want to simplify here. So I'm going to have n plus 2 squared plus 8, because that's 12 minus 4, and that's going to equal 6. Well, now this problem looks just like the completing this, using the square root method that we just did in the section above. So I'm going to subtract 8 from each side. I have n plus 2 squared equals negative 2. When I take the square root of each side, this is what we just talked about, or when we have a negative inside of my radical, that cannot happen. So the answer here is no solutions. If we look at number 30, we're still going to group the ax squared and the bx values together. And then I want to ask myself, is there anything in common between 2 and 16? We know that there is a 2 in common between those numbers. So 2 divided by 2 is 1, so 1a squared. Negative 16 divided by 2 is negative 8, so negative 8a. I'm going to want to complete the square and then finish it out with plus 83. And then whatever I put in, I'm going to also have to take out. So that's going to be minus a blank equals negative 2. Well, the steps for completing the square is to look at my b value, which is here, the negative 8a. And I want to divide that in half. So half of negative 8 is negative 4. Notice that's going in parentheses because when we square it, it's going to turn into a positive value. But when I balance to go take it out, I have negative 4 squared. I can't forget that I had distributed this 2 into everything that was inside my parentheses. So I also have to take out the 2 that's being multiplied. When I write this as vertex form, we get 2a, and this time it's going to be minus 4 because that negative 4 is what we found to be half of our b value, squared. That's plus 83 minus 4 squared is 16 times 2, 32. That's going to equal negative 2. We want to simplify. When we simplify, we get 2 times a minus 4 squared plus 51 equals negative 2. And we want to subtract 51 from each side. So we get 2a minus 4 squared equals negative 53. And we divide each side by 2. we have a minus 4 squared equals, I'm just going to leave it negative 53 over 2. And as we go to take the square root of each side, I notice that I have a negative inside the square root, so this answer is also no solution. So when we solve using quadratic formula, we just need to remember what the quadratic formula is. So that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we just have to have our equations in standard form, and then we need to identify a, b, and c, and then plug this into the calculator with our formula. Remember, this formula will be provided for you on the test. So I first noticed that this does not equal 0, it's not in standard form. So I'm going to start by adding 4 to each side. So I get 2n squared plus 10n minus 132 equals 0. Then I just want to identify my a, b, and c values. So a equals 2, b equals positive 10, c equals negative 132. And then I want to take these values and plug them into my formula. So negative 10 plus or minus the square root of 10 squared minus 4 times 2 times negative 132. All of this is going to be divided by 2 times 2, my a value. Now remember, you can't put a plus and minus sign in the calculator at the same time, so you're needing to type this in with a plus sign and then redo the problem with a minus sign. You should always have two answers here. So I got my two answers to be x equals 6 and x equals negative 11. Just make sure that you have every part as you get ready to type it into the calculator. When we get into the word problems, we have to make sure we know what the problem is asking. So it says the product of two integers, and we know that product means multiply, is 45. The same two numbers have a difference, which means subtract, of 4. And they want to find the possible pairs of these numbers. So I just want to make a factor list of 45. So 1 and 45, 2 will not go, 3 and 15, 4 will not go, 5 and 9. 6 won't go, 7 won't go, 8 won't go, and we're back to 9. So out of this list, we want to know the two that have a difference, so when you subtract them, they equal 4. And we can see right away that that is 5 and 9, so my answers are 5 and 9. For the second word problem, we have one side of a rectangle is 4 inches shorter than 3 times the other side. We want us to find both sides of the rectangle. Well, I know that one side has to be x. The other side is 3 times, so 3x, and 4 inches shorter, so 3x minus 4. I also can see that it tells me the area, and I know that in order to find area, that is length times width. So I'm going to take these two side values and multiply them together. X times 3x minus 4, and that's going to equal 119, and that comes right out of the problem where they told me. So x squared, or 3x squared minus 4x is going to equal 119, because all I did was distribute the x into the problem. Well, I want this to be in standard form, so I'm going to subtract 119 from each side, where I get 3x squared minus 4x minus 119 equals 0. At this point, I can just go back and type this into my quadratic formula, so I have my a, b, and c values. I have negative 4 plus or minus the square root negative 4 squared minus 4 times 3 times negative 119. That's my a, b, and c values, and then I'm going to divide by 2 times 3. Now, when I type this into the calculator, I'm going to get two answers. One's not going to really make sense here, so I think you get a negative 11 and a positive 7. We're talking about distance, so distance cannot be negative. So I'm just going to ignore that first answer I got. So I get x equals 7. But remember, it's asking me to find both sides of the rectangle. So I need to come up here and plug in a 7 for the other side of the rectangle. So 3 times 7 is 21. 21 minus 4 is 17. The two side lengths of the rectangle is 7 and 17. Finally, for the last word problem, we have an object launched straight up in the air can have its height h in feet at t seconds, modeled by the equation h of t equals negative 16t squared plus 64t plus 6. So part A, when does the object reach its maximum height, and what is its maximum height? So really this is just asking me for the vertex of the equation. Remember, t will be my x value, and then h for height will be my y value. So to find this x value, I need negative b over 2a. If I come back to my equation here, this would be my a, b, and c values. So for part A, I've got negative 64 divided by 2 times negative 16, which gives me negative 64 divided by negative 32. It takes 2 seconds for this object to reach its maximum height. And then to find out what the maximum height is, I simply want to plug 2 in to anywhere I see a t. So negative 16 times 2 squared plus 64 times 2 plus 6. When you put all that into your calculator, you should get that the maximum height is 70 feet. Part B wants to know what times will the object be at 54 feet off the ground. Notice it's times with an S. That's because the shape of this projectile is a parabola. If the height is 70, that means I'm going to have to pass 54 feet 2 times. So all I'm going to do here is use quadratic formula. I'm taking the equation negative 16t plus 64t plus 6, and I'm going to set that equal to 54. Then we're going to get it in standard form, so I can use quadratic formula. Subtract 54 from each side. So I get negative 16t squared plus 64t is going to be negative 48. Minus 48 equals 0. Well, here are my values that I'm going to put into the quadratic formula, a, b, and c. So negative 64 plus or minus the square root of 64 squared minus 4 times negative 16 times negative 48 divided by 2 times negative 16. And again, you can't put plus and minus both into the calculator at the same time. So you'll put in the plus side where you should get 1 second. Then you'll put in the minus side where you should get 3 seconds. So at the times when this object is at 54 feet is after 1 second of it being launched and after 3 seconds of it being launched. Finally, the question wants to know when will the object return to the ground? That's just asking for my x-intercept. So I want to come back and use quadratic formula, but I want to use quadratic formula from my original equation. So negative 64 plus or minus square root of 64 squared minus 4 times negative 16 times 6, all divided by 2 times negative 16. Now, we've got to put both sides of this into the calculator, so the plus and the minus. When you do the plus side, you should get negative 0.0901. And when you do the minus sign, you should get positive 4.0901. Now, you have to think about this as time, and it's not feasible to have negative amounts of time, so it'll take 4.09 seconds for this object to come back to the ground.